On August 9, 1942, at the end of a 1,000-mile long-range patrol, two P-38 Lightnings of the 343rd Fighter Group, 11th Air Force, stumbled across a pair of Japanese Kawanishi H-6K Mavis flying boats and sent them down, becoming the first Japanese aircraft destroyed by Lightnings. The clash over the icy Aleutian seas was small in scale, but notable in consequence. Confident in their defensive guns and unaware that such a fighter existed, the Japanese crews held their course as the unfamiliar twin-boom silhouettes appeared. Within minutes, both flying boats were burning wreckage on the frigid northern water, felled by a fighter they had never seen before. 4.5 months later, on December 27, 1942, the morning air above New Guinea was thick with tropical humidity as 12 P-38F Lightnings of the 39th Fighter Squadron sat on strip alert at a forward field. First Lieutenant Kenneth Sparks was carrying out his pre-flight inspection on P-38F serial number 42-12651. The aircraft's shark mouth, nose art crouched in the dawn light while the blue spinners on its twin Allison engines caught the first sun filtering through the jungle. New to the theater, these fighters represented a radical shift in air combat that would soon overturn Japanese expectations. The pilots had been briefed the night before by Captain Thomas Lynch, their squadron commander, and an ace with 5 hard-won victories in Bell P-39 Airacobras. Lynch, a careful tactician who had survived the war's difficult opening months, appreciated the significance of what they were about to prove, and told them they would demonstrate why the Lightning changed everything, insisting on strict altitude discipline, ordering no one below 20,000 feet, and directing them to make the enemy come to them because they could not match the Lightning at altitude. From Rabaul, about 400 men to the northeast, the Imperial Japanese Navy's 11th Air Fleet launched what it expected to be a routine strike of roughly 60 aircraft. ID-3A Val dive bombers escorted by Mitsubishi A-6M, fighters and Nakajima Ki-43 Oscar, fighters from the Japanese Army Air Force. The mixed composition reflected the inter-service cooperation forced by mounting American resistance across New Guinea. Among the Zero pilots was Petty Officer First Class Kazu Sonoda, a veteran of the China Campaign and the Darwin Raid. With 12 victories to his credit, Sonoda personified the confidence of Japanese naval aviation. His A6M3 Model 22, fitted with clipped wings for a crisper roll rate, represented the latest effort to preserve the Zero's edge, an effort that incremental improvements alone could not ultimately overcome. The P-38's origins reached back to an entirely different America in 1936, when isolationist sentiment was strong and the Army Air Corps remained underappreciated. In February 1937, the Corps issued Circular Proposal X608, calling for a high-altitude interceptor capable of 360 mph at 20,000 feet and armed with heavy firepower, specifications that no existing fighter then approached. Lockheed's answer, drawn up by a young engineer named Clarence Kelly Johnson and his team, flouted conventional fighter design. Rather than rely on a single engine, they proposed twin Allison V-1710s. Instead of a standard fuselage, they placed the pilot and armament in a central nacelle connected by slender booms to twin tail fins. The radical layout promised to meet the demanding specification, though many doubted such an unconventional design could succeed. The prototype XP-38 first flew on January 27, 1939 with Lieutenant Benjamin Kelsey at the controls, and its performance vindicated Johnson's gamble. 2 weeks later, while attempting a transcontinental speed run from California to New York in 7 hours and 2 minutes, Kelsey crash-landed at Mitchell Field when his engines failed on approach. Despite that setback, the Army ordered 13 YP-38 service test aircraft and then production contracts that eventually exceeded 10,000 machines. What made the P-38 revolutionary was not merely its unusual appearance, but its superiority across several key performance measures. Its twin-turbo supercharged engines held power at altitudes where other fighters lost performance. By comparison, the Zero's Nakajima Sakai 21 produced about 950 horsepower at sea level, but dropped to roughly 750 horsepower by 20,000 feet. The P-38's Allisons delivered usable power to 25,000 feet and beyond, a difference that was more than numerical and actually changed what fighters could do. The turbo supercharging system itself was an engineering feat Japan could not match. Each engine used a General Electric Type B turbocharger that harnessed exhaust gases to spin a turbine which compressed incoming air. That turbocharging arrangement kept the engine supplied with near sea-level air pressure even when the airplane climbed to extreme heights. The whole installation, wastegates, intercoolers, and the complex control gear demanded advanced metallurgy and precision manufacturing that pushed U.S. industry hard and well outpaced what Japanese factories could produce. The Lightning's firepower was another leap forward. 4 Browning 50 caliber machine guns and a single Hispano 20mm cannon clustered in the nose formed a lethal, focused cone of fire. Wing-mounted guns, by contrast, relied on careful convergence settings and lost punch at longer ranges, but the P-38's nose armament kept its streams aligned over distance. Japanese pilots trained to close to roughly 200 yards for effective convergence with wing guns suddenly found themselves under accurate, deadly fire well beyond 400 yards. When dawn broke over New Guinea on December 27th, the scene was set for a clash that would rattle Japanese airmen. The P-38 patrol had lifted off at 0600 and climbed cleanly into the brightening sky. Alongside Captain Lynch and Lieutenant Ken Sparks were seasoned flyers and eager newcomers testing themselves in the squadron's new mount. Richard Bong, temporarily attached from the 9th Fighter Squadron while his unit awaited its Lightnings, was among them. Raised on a Wisconsin farm, he had shown rare aptitude in training, though his instructors worried about an aggressive streak that in combat would help make him America's top ace. The Japanese formation coming out of Rabaul followed its usual profile dive bombers at about 15,000 feet, with fighters weaving at roughly 18,000 feet, led by Lieutenant Commander Kakuichi Takahashi, a Pearl Harbor veteran with many similar missions under his belt. For months, American interception had been difficult because the P-39s and P-40s struggled at altitude, so the strike looked routine. Coast watchers on occupied islands, however, passed the warning and Lynch had time to place his fighters wherever they would be most effective. The Lightnings pushed through 20,000 feet with their turbochargers holding power where normally aspirated engines would sag, and at 25,000 feet they leveled off and circled, poised above. "Bogey's 2 o'clock low," called Lieutenant Charles Sullivan, who had also moved over from P-39s, and Lynch answered that he could see them and ordered them to keep the altitude advantage, make a single pass through the escorts, then press the bombers and avoid turning engagements. Below, the Japanese formation lumbered on, scanning the skies at their own height and lower, the standard visual routine that had worked for years, and none of the Zeros looked high enough to spot the Lightnings against the sun. Petty Officer Kanoda first realized something was wrong when his wingman suddenly detonated. He twisted to locate the source and saw unfamiliar twin-boom silhouettes diving at tremendous speed. His startled radio call came too late. Lynch had rolled inverted and pulled through onto a Key 43 Oscar and at about 300 yards opened fire. The P-38's concentrated nose armament cut the Oscar cleanly in two. The severed sections tumbled earthward in separate spirals. Bong, following Lynch's lead, picked out a Zero struggling to climb, and put it down in a ball of flame, his first confirmed victory in the airplane that would make his name. Sparks dove on another element and his Lightning accelerated past 400 MEPA, a regime where the Zero's fabric-covered controls stiffened and became nearly unworkable. The flimsy control surfaces couldn't overcome the high aerodynamic forces, while the P-38's metal structure and, on later machines, hydraulically boosted controls stayed responsive. Sparks fired a long, steady burst into a diving Zero and watched tracers find their mark. Without self-sealing tanks, the enemy's fuel ignited instantly, pulling up on the Lightning's superior climb rate to regain altitude. Sparks saw a second Zero try to follow, but it stalled in the thin air and fell away in an unrecoverable spin. The whole action was over in under 10 minutes, but felt much longer to those involved. When the Lightnings reformed, the Japanese formation was fragmented and littered with burning wreckage. American air crews initially claimed 11 enemy aircraft, though post-war study indicates the true toll was probably 7 or 8. Sparks' P-38 had taken heavy damage and he crash-landed at Doadora, emerging with only minor injuries. The engagement illustrated a deeper technical gap rooted in differing design philosophies and industrial limits. Japanese engineers had sacrificed armor, self-sealing tanks, and even radios in many planes to save weight and maximize maneuverability, while American design and manufacturing emphasized protection, durable construction, and systems, choices that in this fight proved decisive. That design choice had worked against lesser foes, but proved disastrous when matched with the P-38. American engineers took the opposite route. They built the Lightning to survive as well as perform. Armor shielded the pilot from rifle-caliber fire. Fuel tanks were self-sealing to withstand multiple hits without erupting, and the airframe was rugged enough to take damage that would have ruined lighter fighters. This was not needless excess. It reflected the judgment that keeping the pilot alive mattered as much as speed or agility. The turbocharger deserves special emphasis because it embodied technology Japan simply could not reproduce. The unit ran at temperatures above 1,500 degrees and required exotic alloys to tolerate the heat. The elaborate network of ducts, intercoolers, and wastegates had to operate faultlessly from Arctic chill to tropical swelter. General Electric's engineers solved these problems after years of work, giving the P-38 a high-altitude capability unmatched by the Japanese. 4 days later, on December 31, 1942, Ken Sparks was airborne again despite his recent forced landing. The young lieutenant had spent the intervening days helping his crew chief patch battle damage across the squadron and learning how robust the Lightning really was. Now strapped into P-38F serial number 42-112652, he joined another interception as the Japanese attempted a New Year's Eve raid on Allied positions. Radar, another advantage the Japanese lacked, warned of the incoming strike, and the Lightnings climbed to their chosen altitude, circling and waiting for the enemy to enter their envelope. This time, the Japanese tried to blunt the Lightning's edge by keeping their fighters unusually high. When the two formations met, Sparks found himself in a direct head-on run with a resolute Zero pilot. In such passes, the P-38's nose-concentrated armament was decisive. All weapons could be delivered together while the Zero's wing guns would not come to effective convergence until much closer. At the last instant, the Japanese pilot banked hard left but misjudged spacing or the P-38's wingspan. His wing clipped Sparks' right wing, tearing away several feet. The lighter Japanese structure could not survive the impact. Its wing tore free and the Zero plunged into the jungle. Sparks wrestled his damaged Lightning back into control. The twin-engine layout that critics had called needlessly complex now paid off. By trimming power between engines, he retained enough control to bring the crippled fighter back to Doadora for another crash, landing his second within 5 days, and walked away with little more than bruises thanks to the P-38's sturdy cockpit. That episode also underscored a less heralded benefit. The P-38's tricycle landing gear. Unlike the Zero's tail-dragging setup, which was trickier to handle and prone to ground loops, the nose wheel made damaged landings far more forgiving. Small design details like this increased the odds that experienced aircrews would survive forced recoveries and return to fight another day. The psychological effects on Japanese naval aviators went well beyond the tally of aircraft. For 2 years, the Zero had symbolized Japanese technical mastery and Yamato Damashi, national spirit, and pilots built their identity around the plane's apparent invulnerability. The Lightning didn't only beat Zeros in battle. It overturned the belief system that had sustained their confidence. Lieutenant Masashi Machino, a Rabol squadron leader whose diary was captured when the base fell, wrote in January 1943 that the twin-tailed fighters had altered everything. Young flyers were now afraid before takeoff, knowing Americans waited above where they could not reach or even see. Hunters had become the hunted. He expressed real worry for the future of their naval air arm. The technical intelligence struggle intensified as both sides tried to catalog one another's strengths. Japanese examination of crashed P-38 wreckage revealed the depth of America's manufacturing lead. A February 1943 Naval Air Technical Arsenal report, based on wreckage study, lamented the precision of U.S. mass production. Components made to tolerances Japan could not match, engine bearings to unattainable specifications, electrical materials unavailable to them, hydraulic systems running at pressures beyond their equipment. Most strikingly, analysts estimated the turbocharger technology would take about 5 years to replicate, even with access to the right raw materials and machine tools. Deemed too demoralizing for wide distribution, the report stayed classified, but those technical readers who saw it concluded Japan had irretrievably fallen behind. The human cost of that gap grew worse through 1943. Japan's once rigorous pilot training. Pipeline unraveled under losses. An elaborate 2-year program was shortened to a year, then 6 months, and finally to only weeks to fill desperate needs. Ensign Ichiro Yamada, a composite figure drawn from many accounts, arrived at Rabaul in March 1943 with barely 150 hours of flight time and scant combat instruction. Then was expected to face Americans with triple his experience flying machines that outperformed his Zero in nearly every dimension. His first sortie was his last. He was downed by P-38s he never even saw because they attacked from an altitude he could not reach. American maintenance and logistics, though less dramatic, were equally decisive. P-38 units routinely kept more than 75% of their aircraft serviceable, despite operating twin engines under primitive field conditions, a reliability born of systematized upkeep that astonished Japanese observers. Master Sergeant Frank Chen of the 81st Fighter Squadron embodied that ethic. His meticulous records tracked every swap, every inspection, every tiny tweak. "The tech manual is the Bible," he told new mechanics. "Follow it exactly and the bird will fly. Take shortcuts and pilots die." This disciplined approach, mirrored by hundreds of crew chiefs, kept P-38s flying when Japanese units often struggled to keep half their inventory airworthy. Lockheed in Burbank fed a vast spare parts network that funneled components to forward bases. Critical parts were flown in within days, and routine supplies arrived by Liberty ship. Convoys under Escort, the very air superiority Lightnings, helped secure Japanese attempts to plug their parts shortfall revealed the industrial gulf. Where American squadrons received standardized, interchangeable components, Japanese mechanics often had to hand-fit items to each airframe. The Zero's Sakai engine, nominally a standard unit, varied between production lots so much that parts from one engine might not fit another without extensive rework. By contrast, the P-38's Allison power plants were models of interchangeability. Technical Sergeant Rodriguez of the 8th Fighter Squadron could rebuild an engine from mixed parts without modification. After the war, he recalled combining pieces from 3 wrecked engines to make one serviceable unit in hours rather than days. As the U.S. campaign widened in 1943, the P-38's long legs reshaped strategy. With drop tanks, the Lightnings could escort bombers to targets once thought safe behind enemy lines, exposing Japanese bases that had enjoyed relative sanctuary. That sense of nowhere being secure deeply unnerved Japanese commanders. On March 2, 1943, 16 Lightnings of the 39th Fighter Squadron escorted B-17 Flying Fortresses on a strike against shipping at Wewak, more than 500 miles from their base. The sudden arrival of P-38s over what was assumed to be a safe harbor sent shock through Japanese command. Lieutenant Richard Sue, in his first combat in the P-38 after moving over from P-39s, described the Lightning's stability in a high-speed dive, where the P-39 felt like a bucking bronco. The P-38 behaved like driving a Cadillac, smooth, powerful, completely under control even at 450 miles armed. The April 18, 1943 mission to intercept. Admiral Yamamoto's aircraft elevated the P-38 from a tactical advantage to a strategic instrument. The plan itself seemed audacious. Fly at wave-top height for 435 miles to avoid detection, then arrive at a precise time and place to catch a single high-value target. That lightweight, turn-first approach had worked against weaker foes but proved deadly when confronted by the P-38. American designers chose a different path, building the Lightning for survivability as well as speed. Armor plates shielded the pilot from rifle-caliber fire. Fuel tanks were fitted with self-sealing linings to survive multiple hits without bursting into flames, and the structure was rugged enough to absorb damage that would shatter more fragile fighters. This was not needless overbuilding, but a deliberate decision that pilot survival was as important as aerodynamic performance. The turbocharger installation deserves special notice because it embodied engineering Japan could not match. The unit ran at temperatures above 1500 degrees and required exotic heat-resistant alloys. Its maze of ducts, intercoolers, and wastegates had to operate reliably from Arctic cold to tropical heat. And after years of development, General Electric solved those problems, giving the P-38 a high-altitude capability the Japanese simply lacked. 4 days later, on December 31, 1942, Ken Sparks was back in the air despite his recent forced landing. He had spent the interim helping his crew chief repair battle damage across the squadron and seeing firsthand how tough the Lightning was. Now strapped into P-38F serial number 42-12652, he joined another interception as Japanese forces attempted a New Year's Eve raid. Radar, another advantage the Japanese did not possess, provided early warning, and the Lightnings climbed to their chosen ceiling to wait. The attackers, attempting to blunt the Lightning's edge, held their fighters unusually high. When the formations closed, Sparks found himself in a head-on pass with a resolute Zero pilot. In such straight-on encounters, the P-38's concentrated nose battery was decisive because all weapons delivered together, while the Zero's wing guns would not converge until much closer. At the last instant, the Japanese pilot banked hard left but misjudged spacing or the P-38's span. His wing clipped Sparks' right wing, tearing away several feet of structure. The lighter Zero could not survive the collision. The wing separated and the fighter spiraled into the jungle. By trimming thrust between the Lightning's two engines, Sparks maintained enough control to bring the crippled airplane back to Doadora for a second crash landing in 5 days, walking away with only bruises thanks to the cockpit's sturdy protection. That episode also highlighted a practical advantage often overlooked: the P-38's tricycle landing gear. A nose-wheel undercarriage made damaged recoveries far more forgiving than the Zero's tail-dragger layout, which was prone to ground loops and required delicate handling. That small design choice increased the chances that experienced crews would survive forced landings and return to combat. The psychological effect on Japanese naval aviation extended well beyond the immediate loss of planes. For 2 years, the Zero had come to personify Japanese technical prowess and Yamato Damashi, and pilots built an identity around the fighter's apparent invulnerability. The Lightning did more than defeat aircraft in combat. It undermined the belief system that had sustained them. Lieutenant Masashi Machino, a rebel squadron leader whose diary was captured when the base fell, recorded in January 1943 that the twin-tailed fighters had altered everything. Inexperienced pilots were afraid even before taking off. Convinced Americans waited unseen above them, and the hunters had become the hunted. He feared for the future of their naval air arm. The technical intelligence struggle deepened as both sides tried to catalog one another's strengths. Japanese examination of downed P-38 wreckage revealed a manufacturing gap that shocked analysts. A February 1943 Naval Air Technical Arsenal report based on wreck inspections complained of U.S. mass production precision. Components made to tolerances Japan could not achieve. Engine bearings to specifications beyond their capacity. Electrical materials they could not obtain. And hydraulic systems running at pressures their tools could not match. Most alarming was the turbocharger technology, which analysts judged would take roughly 5 years to reproduce even with access to the right raw materials and machine tools. The report was kept highly classified because it was so demoralizing, but those technical readers who saw it drew the same conclusion. Japan had fallen irretrievably behind in key aerospace technologies. That technological gap had tragic human consequences as 1943 wore on. Japan's once rigorous pilot training pipeline collapsed under losses. A 2-year program was whittled first to a year, then to 6 months, and finally to mere weeks to produce replacements. Ensign Ichiro Yamada, a composite figure drawn from multiple accounts, arrived at Rabaul in March 1943 with roughly 150 hours of flying and minimal combat instruction, and was expected to face Americans with 3 times his experience in superior machines. His first sortie was also his last, down by P-38s, operating from altitudes he could not reach or even see. Less dramatic but equally decisive was American maintenance and logistics. P-38 squadrons routinely kept more than 75% of their aircraft operational, despite the complexities of twin-engine service in primitive forward conditions, a reliability born of systematic upkeep. Master Sergeant Frank Chen of the 81st Fighter Squadron exemplified that ethic. His meticulous logs recorded every part's change, inspection and minor tweak, and he drilled into new mechanics that the technical manual was treated as scripture. Follow it exactly, and the airplane will fly. Cut corners and pilots die. That disciplined approach, replicated across hundreds of crews, kept Lightnings flying while Japanese units often struggled to keep half their complement serviceable. Lockheed's Burbank plant supplied a vast spare parts network to forward bases. Critical components were airlifted within days and routine supplies arrived by escorted Liberty ship convoys protected by the very air superiority the P-38s provided. Japanese efforts to make up for the parts shortfall only emphasized the industrial gulf. Whereas American squadrons received standardized, interchangeable components, Japanese mechanics often had to hand-fit parts to individual airframes. The Zero Sakai engine, nominally standardized, varied enough between production lots that parts from one batch might not fit another without extensive rework. By contrast, the P-38's Allison power plants were models of interchangeability. Technical Sergeant Rodriguez of the 8th Fighter Squadron could rebuild an engine using mixed parts without adjustment, and later recalled combining pieces from 3 wrecked engines to make one serviceable unit in hours rather than days. The Lightning's long-range reshaped Allied strategy in 1943 with external drop tanks. Lightnings could escort bombers to targets once thought safe behind enemy lines, turning previously sheltered bases into vulnerable objectives and deepening Japanese demoralization. On March 2, 1943, 16 Lightnings of the 39th Fighter Squadron escorted B-17, flying fortresses to strike shipping at Wewak, more than 500 miles from their base, and the sudden appearance of fighters over what had been considered out of range sent shock through Japanese command. Lieutenant Richard Sue, in his first combat in a P-38 after converting from P-39s, contrasted the machines. Where the P-39 bucked in a high-speed dive, the Lightning felt as smooth and controlled as a luxury sedan. Even near 450 matches, the April 18, 1943 operation to intercept Admiral Yamamoto's flight elevated the P-38 from a tactical asset to a strategic weapon. The plan called for a wave skimming run of roughly 435 miles to avoid detection, and then to arrive at a precisely timed point to seize a single high-value target. Only the P-38 combined the fuel endurance, navigation instruments, and flight characteristics needed to pull off such a mission. Major John Mitchell planned every element down to the gallon, plotting courses that accounted for wind drift over hundreds of miles of open ocean, and timing the rendezvous to the second. Arrive too soon, and Yamamoto would not be present. Arrive late, and he would be under base protection. 16 P-38s lifted from Henderson Field on Guadalcanal under strict radio silence, skimming roughly 50 feet above the waves to evade radar and enduring more than 2 hours of fatigue and monotony with nothing but water and sky as landmarks. Everything rested on Mitchell's math and the dependability of the airplanes. Lieutenant Rex Barber, flying in the section assigned to strike Yamamoto's plane, later recalled the long, tense hours over open sea, constantly checking fuel gauges and doubting the numbers, until, at the precise moment Mitchell had predicted, the dark ridge of Bougainville loomed ahead and, 30 seconds later, the enemy bombers came into view. The interception unfolded with clockwork timing. Yamamoto's 2 G4M Betty bombers, screened by 6 Zeros, were met as planned. The Lightning's jettisoned external tanks surged to attack speed, and the engagement ended with both bombers down and Yamamoto's aircraft crashing into the jungle. The death of the architect of Pearl Harbor, taken by the very machines and tactics he had dismissed, sent a shudder through Japanese forces. If even Yamamoto could be picked off so precisely, no senior commander or secure base was immune, and the myth of inevitable Japanese air superiority collapsed, the human toll of that technological gap only. Accelerated through 1943, replacement. Pilots arrived with scant training and negligible live fire experience. Thrown against veteran American airmen flying superior machines, their survival prospects were measured in weeks or days. Lieutenant Yukioki, who would later head the first formal kamikaze unit, wrote home in mid-1943 that new flyers looked like boys, could barely hold formation, and were being sent up against American twin-engine fighters with little chance of return. It is murder, not war, he feared. The maintenance crisis worsened as skilled technicians were lost or pulled into pilot training. Seasoned master mechanics were replaced by teenagers with a few weeks of instruction, and systems that had been manageable under experienced hands turned lethal in the field. Chief Petty Officer Yamamoto, a veteran mechanic at Rabaul, despaired that replacements do not understand the engine, only which bolts to turn, and spent more time undoing their errors than performing proper upkeep. By contrast, American pilot training and unit organization expanded and improved. By mid-1943, P-38 pilots arrived in theater with more than 500 hours total time, including at least 100 hours in type, having practiced high-altitude combat, engine-out drills, long-range navigation and tactics honed in combat. The 475th Fighter Group stood up in Australia in May 1943 and organized from the start as a Lightning outfit, trained exclusively on P-38 tactics. Combat veterans mentored newcomers, and the group soon posted victory ratios better than 10-1. Major Thomas Maguire, who joined the 475th in July 1943 and would become America's second highest scoring ace, preached a methodical doctrine. Use the P-38's speed, altitude, firepower, and range, and never surrender any of those advantages. The Zero only becomes dangerous if you fight on its terms. That disciplined approach yielded dramatic results. On August 21, 1943, Maguire downed 5 Japanese aircraft in a single sortie without taking damage, and his after-action reports read like applied physics, energy management, angle geometry, and speed differentials, replacing the old romantic notions of dogfighting. Japanese efforts to counter the Lightning showed ingenuity, but also desperation. Twin-engine responses, such as the Kawasaki K-45 Nick, lacked the Lightning's high-altitude performance and proved vulnerable, while the Nakajima Ki-84 Frank had better ceiling but arrived too late and in too few numbers. Technical investigations of wrecked P-38s grew frantic, and Army Aerotechnical Research Institute report in Tokyo dated September 1943 warned that the enemy's turbo-supercharger metallurgy and turbine blade alloys were beyond Japanese production capability, and that matching the system would require roughly 5 years even with the necessary materials and machine tools. The P-38's F-5 photo reconnaissance versions added insult to injury. Unarmed Lightnings photographed Japanese dispositions daily from altitudes and speeds too great for interception, creating the constant feeling of being watched. As one staff officer, Colonel Masanobu Tsuji, lamented privately, American photoplanes revealed everything within hours and left Japanese forces exposed and without secrecy. On the ground, the Lightning's presence carried clear consequences. Able to carry bombs and rockets as well as heavy nose armament, the P-38 proved a fearsome ground attack platform. Anti-aircraft crews found the twin-tailed fighters diving from heights their guns could not reach. Sergeant Hiroshi Tanaka of an AA battery complained that by the time his 25mm crews could acquire targets, the Lightnings were already pulling up, attacking from twice the effective engagement altitude of his weapons. The P-38's role as a bomber escort transformed strategic operations. With external tanks, Lightnings could accompany bombers to targets once thought safe behind enemy lines, exposing previously protected bases and deepening enemy demoralization. On March 2, 1943, 16 Lightnings of the 39th Fighter Squadron escorted B-17 Flying Fortresses against shipping at Wewak, more than 500 miles from base, and the sudden arrival of fighters over what had been assumed out of range stunned Japanese command. During a November 2, 1943 low-level strike on Rabaul Harbor, 5th Air Force B-25 Mitchells escorted by P-38s inflicted heavy damage while suffering minimal bomber losses, underlining that Rabaul was no longer a secure bastion. None of this would have been sustainable without the American logistics system. Forward bases stocked vast fuel farms of high-octane gasoline. Ammunition depots held millions of rounds, and spare parts warehouses contained everything from spark plugs to complete engines. That material abundance, parts, flown in within days when critical and routine supplies shipped under Escort, enabled continuous operations that steadily wore down Japanese resistance. Leadership emphasized system over individual glory. Lieutenant Colonel Charles MacDonald took command of the 475th late in 1943 and stressed systematic excellence. "We are not trying to make aces. We are trying to destroy enemy air power. Every pilot who returns can fly tomorrow. Every Japanese pilot we eliminate is one they cannot replace. It's arithmetic, not glory." That mindset, backed by the P-38's survivability, self-sealing tanks, armor, and rugged construction, produced steady attrition. American air crews accumulated experience while Japanese expertise dwindled. Finally, superior navigation and avionics multiplied American effectiveness. P-38s carried radio compasses that homed on beacons for hundreds of miles, precise chronometers for dead reckoning over water, and radio altimeters for exact height readings, tools that seemed miraculous to opponents still relying on magnetic compasses and visual fixes. Captain Robert DeHaven, credited with 14 P-38 victories, later recalled a mission where low clouds closed in 300 meters from base. By tuning the radio beacon and following instruments, he flew through the weather with certainty about his position when other types would have been in grave danger. The Japanese airmen we captured admitted they would have been forced to abandon their aircraft under the same conditions. Communication proved equally decisive. American P-38s used dependable VHF radios that allowed intricate, coordinated tactics. Flight leaders could direct multiple elements, push them onto targets, or alert them to danger, while ground controllers armed with radar vectored intercepts beyond visual range, turning lone fighters into a networked weapon. Japanese radio gear, by contrast, remained notoriously unreliable. Many crews flew with broken sets or removed them to save weight, relying on hand signals and prearranged plans that could not adapt to unfolding battles, a paralysis that made them vulnerable to synchronized American attacks. The strategic consequences surfaced in the decision to evacuate Rabaul. Once a linchpin of Japanese air power, the base became indefensible under relentless P-38 pressure, and the February 1944 withdrawal of remaining aircraft admitted, in effect, that control of the skies had passed to the Americans. Stranded without fighter protection, a garrison of more than 100,000 troops was effectively cut off. Admiral Junichi Kusaka, facing the losses, argued that preserving the remnants for inner defenses was wiser than sending planes to be destroyed and pilots to be lost. The cultural shock went beyond military planning. Letters censored during the war but uncovered later reveal a shift from confident warriorhood to bleak resignation. Pilots who had once written bravado now penned farewells. Lieutenant Fujio Kuroki's December 1943 letter mourned that the enemy's twin-engine fighters had rendered their sacrifices futile, taking off to face opponents they could neither reach nor escape, and he begged to be remembered as he had been before the war turned. Dying into duty, American maintenance training established a new benchmark. Where Japanese apprenticeship systems took years to produce skilled mechanics, U.S. programs emphasized systematic instruction and principles over rote repetition, producing competent technicians in months. Technical schools in the States turned out thousands trained in hydraulics, electrical systems, and engine theory, arriving in theater with standardized skills that could be applied immediately, a production line approach to human capital that Japan could not match. The spare parts ecosystem deserves special notice. Thousands of American subcontractors manufactured components to tight specifications, a bearing maker in Detroit, a hydraulic firm in Los Angeles, an electrical plant in Chicago, each contributing to a vast distributed supply chain. Rigid quality control made parts interchangeable, a capability that astonished Japanese mechanics, and the geographic spread of production provided resilience. If one plant was damaged or overloaded, output could shift elsewhere. Japan's concentration of industry in a few facilities left it vulnerable to the bombing that P-38s and their escorts would facilitate. By early 1944, the change in the air war was unmistakable. Japanese airmen no longer spoke of triumph, but of postponing defeat. The sight of P-38s over a battlefield meant tactical failure for their side, the only question becoming how costly the resistance would be. General Tomoyuki Yamashita, planning the Philippines' defense, bluntly advised preparing as if air support did not exist. The new twin-engine fighters had rendered their aircraft largely irrelevant. The U.S. pilot rotation system amplified advantages. Experienced veterans returned home to teach, passing hard-won lessons to hundreds of trainees. Richard Bong, on a training tour in early 1944, stressed practical doctrine over old-school dogfighting theory, teach recruits boom and zoom tactics, one high-speed pass, then climb away, never trade speed and altitude for a turning fight the zero favored. That institutional learning loop meant each incoming cohort was better prepared than the last, with syllabi updated rapidly to reflect battlefield experience and mock combats drilling students in likely enemy tactics. Japan's training pipeline, by contrast, collapsed into expediency. The elaborate spiritual and technical preparation of the pre-war era gave way to hurried, minimal instruction. Ammunition shortages curtailed live fire practice, and new pilots often learned only takeoffs, landings, and basic formations. Ensign Koshi Ogawa, posted to Clark Field in October 1944 with only 80 hours and having fired his guns twice, recorded in his diary that he felt like a sacrifice, sent, up against foes he could not match, desperate. Technical inquiries followed every captured or forced down P-38, a relatively intact P-38G examined by the Army Air Technical Research. Laboratory revealed features that Japanese engineers admired and feared. Widespread flush riveting to cut, drag, sealed bearings in control gear, automatic circuit breakers in the electrical system, and engines produced to mass production tolerances their industry could not replicate. Evidence not merely of a superior airplane, but of an industrial base beyond Japan's reach. Radar-equipped night variants of the Lightning extended the threat into darkness. Though not as optimized as dedicated night fighters, radar-fitted P-38s could locate and attack Japanese aircraft attempting to operate at night, shattering the consolation of darkness. Lieutenant Kenji Yoshida, on night reconnaissance in a modified Zero, described abruptly seeing tracers from an unseen attacker and realizing he could be found even in complete black. How do you hide from an enemy that sees at night? Carrier operations and naval strategy were affected deeply. As P-38s extended their reach from land bases, carriers that once operated with relative freedom became exposed to strikes hundreds of miles from shore. The mobility that had been Japan's naval strength turned into a liability when enemy fighters could find and hit ships far from their own air cover. Vice Admiral Teo Kurita lamented that carriers had become floating targets for land-based fighters and that the mobility advantage had eroded. Even weather gathering and planning benefited the Americans. P-38s climbed above tropical systems to report conditions, giving commanders accurate forecasts and the ability to time operations precisely. Colonel David Lee Tex Hill, who transitioned from the Flying Tigers to P-38s, valued that capability. Rather than guessing weather, crews could check conditions hundreds of miles away and plan accordingly. That reconnaissance and escort capability underpinned a bomber offensive that began to choke Japanese industry. Long-range escorts allowed B-29s and other heavy bombers to operate more safely. Once Japanese fighters had to engage the P-38 escorts, they suffered unacceptable losses and could no longer reliably stop strategic raids. Major General Curtis LeMay acknowledged that the Lightning provided the shield necessary to prosecute sustained bombing campaigns that systematically degraded Japan's war-making capacity. In the war's closing year, P-38 dominance became near absolute. Japanese pilots often avoided combat when Lightnings were overhead. Ground forces dug deeper to hide, and the mere silhouette of the twin-boom airplane signaled approaching destruction. Lieutenant General Kyoji Tominaga, overseeing air forces in the Philippines, reported that P-38s appeared at will over airfields, destroying aircraft on the ground and shooting down pilots who dared to take off, describing not a battle, but systematic elimination. The P-38's human legacy lived on after hostilities ended. American crews forged lifelong bonds and held reunions celebrating survival made possible by technology. Japanese veterans carried different burdens, questions about the meaning of sacrifice against overwhelming odds. Meetings decades later captured this complex reconciliation. Former P-38 ace Gerald Johnson shook hands with former Zero pilot Konami Harada and conceded, "We were lucky to have the better plane," while Harada answered, "We were unlucky to face it." At an air show in Aya's 1988, Saburo Sakai told Richard Bong's widow that Bong's aircraft had defeated them not because of greater courage, but because superior technology rendered their courage moot. Japan's post-war industrial rebirth reflected lessons drawn from that technological humiliation. Confronted with the precision and systems engineering of American production, entrepreneurs and engineers, among them Dr. Suero Honda, resolved to build products to comparable standards, embracing systematic quality control and continuous improvement to close the gap they had once suffered. December 27, 1942. The Air Force stands for more than a single tactical victory. It signaled the arrival of a new era in the Pacific skies. Survivors carried back knowledge that rippled through the Japanese military. The Americans had not just fielded a better fighter, but had created an integrated system: design, production, logistics, training, and tactics that could dismantle Japan's military power. Historians continue to study the transformation. The P-38 shot down more Japanese aircraft than any other American fighter, but its true legacy was demonstrating how industrialized technology and systems thinking could overcome tradition and spirit, producing a psychological and material dominance that decided the air war. Today, restored P-38s still turn heads at air shows, their twin booms and the scream of Allison engines, a reminder that in the Pacific, the age of the samurai in the sky gave way to the age of industrial technology, a shift whose lessons about warfare and national